Hi, this is Jessica Dunn, and we're going to be discussing bond yields. The par value of a bond is also known as the face value. It is the amount that you are paid upon maturity. Usually we set that equal to $1,000. At the time the bond is issued, the coupon rate is generally set to the market interest rate so that the bond will sell for its par value. But a seasoned issue, which is one that has already been sold in the primary market, it's no longer a new issue. It is being traded amongst investors. This seasoned issue uh, may not trade at par value because the coupon rate and the market interest rate are likely not the same because market interest rates fluctuate over time and the coupon rate is constant. And so here is a depiction of what happens to the bond's price as it approaches maturity. So this is bond value as the bond approaches maturity. So along the horizontal axis here, we have years to maturity. Notice that as we go out, we are approaching time period 0, which is when that bond does mature, and the face value or the par value of that bond is due. So here we see that we have a bond that is trading at a premium. So it was the coupon rate for this bond is higher than the market interest rate, which therefore drives up the price because demand is higher. And so this bond is trading at a premium. Now, as we approach maturity, notice that the price of this bond falls. So it's continually declining. The market value of the bond is continually declining. That's because the coupon payments are being paid out. And the coupon payments are what determine whether the bond is trading at a premium or discount. Remember, the only reason this bond is trading at a premium is because the coupon payments are higher than the market interest rate. As those coupon payments are being dispersed, there are fewer future coupon payments to affect the price of this bond, and the price of the bond will fall as it approaches maturity. Now, the opposite is true for a discount bond. So here's a bond that's trading at a discount. So it's trading below $1,000. This bond has a coupon rate that is less than the market interest rate. And so as we approach maturity, the price of this bond is going to increase. And it's for the same reason. Because the only reason why this bond is trading at a discount is because the coupon rate, the interest that the bond is paying, the coupon rate, is less than the market interest rate. And so as we approach maturity, there are fewer of these below market coupon payments left to affect the value. The only payment remaining at time period 0 would be that $1,000 par value. So as we approach maturity, this $1,000 par value is going to have a greater and greater weight on that valuation. And so it's going to cause both the premium bond and the discount bond to converge to par value. So the important thing here is that interest rates do change over time, but the coupon rate remains fixed. And we have already covered that when interest rates are greater than the coupon rate, then the market price will be below par value. It'll trade at a discount. And when interest rates are less than the coupon rate, your coupon is paying higher than market interest, so the market price will be greater than the coupon rate and will trade at a premium. As interest rates fluctuate, the price of the bond will also fluctuate. At maturity, the value of any bond would be equal to its par value because at that point, the only cash disbursement left is the par value. The par value of a premium bond the value of a premium bond would decrease to par value. So just like this picture shows, as we approach maturity, the premium bond is falling in value. The opposite is true for a discount bond. As we approach maturity, the discount bond price is going to rise to the par value of $1,000. If the bond was sold at par and market interest rates don't change, then it will always trade at par. Yield to maturity. This is the most widely cited yield when discussing bonds. Yield to maturity is the rate of return that is earned on a bond that is held until maturity. So you do have to hold this bond until maturity to earn this rate of return. It's also called the promised yield. The yield to maturity is usually the same as the market interest rate. It does make some assumptions. It assumes that the bond will not default, so you will receive all interest and principal payments as promised. And it also assumes that the bond will not be called. So let's calculate a yield to maturity. So for calculating yield to maturity, we need to set this up on a timeline, just like we did every other problem. So this is a 10% or 10-year 9% annual bond with a $1,000 par value, and it's currently selling for $887. So if we were to put this on a timeline, the first thing we would do would be to calculate the coupon payment. That's coupon times par divided by compounding frequency. So we have a 9% coupon times $1,000. Divide that by 1, so we have a $90 coupon payment that is due every year for 10 years. Upon maturity, we're going to receive the face value or the par value of the bond for $1,000. This bond is currently selling for $887. So the present value of this bond, if you wanted to purchase it, you would have to outlay $887. So it's a cash outflow. So a negative sign is necessary. N is equal to compounding period times years equals, so that's equal to 10. And we need to calculate IY. Now remember, IY is equal to R divided by M. In this instance, our M is 1. So the rate that you calculate is equal to the nominal stated rate here. So the first step is to clear our time value of money. We have a $90 interest coupon payment that we will receive every year and $1,000 upon maturity. We have 10 years until maturity, and this bond is trading for $887. So the present value. Let's compute the interest rate. So this is the yield to maturity. So the yield to maturity is 10.91%. So if the coupon rate is less than the required return, the bond is going to sell at a discount. If the coupon rate is equal to the required return, that market interest rate, the bond sells at par. If the coupon rate is greater than the required return or that market interest rate, bonds sell at a premium. And if the required return increases, the price of the bond is going to fall. So let's find the yield to maturity on a 10% or 10-year 9% annual coupon bond with a $1,000 par value that is currently priced at $1,134.20. So let's just do some predictions to start with. This bond is selling at a premium. So that tells us that our bond is paying higher than market coupon payments. So the yield to maturity should be less than the coupon rate because we are trading at a premium. So 10 years. So let's calculate our coupon payment first. Coupon times par divided by compounding frequency. So 9% times 1,000 divided by 1 gives us 90. So we're going to receive $90 every year if we purchase this bond, plus $1,000 at maturity. So the future value is equal to that par value or face value of $1,000. And this bond is currently selling for $1,134.20. And we need to put a negative sign in for that because we would have to pay that to purchase this bond. It would be a cash outflow to us. If you forget to put it in a negative sign, then you will get an error 5. It's got 10 years till maturity. And then we're going to solve for our IY. So let's first clear our time value of money. We have a $90 coupon payment, a $1,000 par value. It's currently trading for $1,134.20. And there are 10 years until maturity. Let's compute the IY. And we get 7.08%. So the yield to maturity, the rate of return that we would earn if we purchased this bond today and held it until it matured, is 7.08%, which is less than our coupon rate, and that makes sense because this bond is trading at a premium. It's paying higher than market interest rates. There are some other yields that we need to be aware of. First is the current yield. The current yield is equal to the annual coupon payment divided by the current market price of this bond. The capital gains yield measures stock price appreciation. So it's the change in price from when you bought it to when you sell it divided by the beginning price. And the expected total return is equal to the current yield plus the capital gains yield. So let's do some examples here. We have a 9% coupon 10-year bond that is currently trading for $887 and has a yield to maturity of 10.91%. Let's calculate the current yield. Remember, the current yield is equal to the annual coupon payment divided by the current price. So current yield is equal to coupon payment, and that is annual, divided by the current price. So if this were a semi-annual bond, then you would need to multiply that by 2 to have the annual coupon payment. So let's first calculate that coupon payment. Now to get the annual coupon payment is just the coupon times par, because we're not worried with the compounding frequency because we're wanting to know what is the annual coupon payment. So the coupon rate here is 9%. Multiply that by a $1,000 par, and we get a $90 coupon. So the current yield is equal to that $90 divided by the current price of $887. So that gets us 10.15%. With that information, we can calculate the yield to maturity. We can calculate the capital gains yield. We have both the yield to maturity and the current yield, so we can calculate the capital gains yield. So the capital gains yield would be equal to the yield to maturity minus the current yield, because remember, yield to maturity is equal to capital gains yield plus the current yield that we covered on the previous slide. So right here. So I just rearranged that equation. So our capital gains yield would be equal to that current yield of 10.91% minus the current yield of 10.15%. So that's equal to 0.76%. You could also calculate the capital gains yield by finding the price in year 1 and 2, calculating the difference and dividing by the price in year 1, and you'll get the same answer. But this is a little bit simpler. So what about bonds that are callable? If we have callable bonds, remember that's a form of refinancing. So the interest rates have fallen. The company is going to issue new bonds at a lower interest rate and use the proceeds to pay off the old bonds. And because of that, they're going to have to pay the prepayment penalty, which we call the call premium, because they're paying that note off early. So a callable bond is not going to earn yield to maturity. If interest rates fall, that note is going to be called, and you wouldn't be able to hold that bond until it matured, so you wouldn't earn yield to maturity. So let's calculate the difference here. So we have a 10-year, 10% semi-annual coupon bond with a $1,000 par value. It's currently selling for $1,135.90. So let's pause there for a minute. We see this bond is trading at a premium. The semi-annual coupon rate is 10%. So we know that this bond is paying above market interest rates because it's trading at a premium. And so this bond has an 8% yield to maturity. So that makes sense. This bond may be called after 5 years at $1,050. So we know that the yield to maturity is 8%. But there's a strong likelihood that we won't earn that 8% because market interest rates have already fallen, and this bond is callable. So market interest rates have already fallen, calling this bond to be priced at a premium. So we should expect this bond to be called. So let's calculate our yield to call. So our yield to call, we're going to do everything the same way, except on our timeline, we're going to assume that the bond is called. So let's calculate our coupon payment to start with. It's equal to coupon times par divided by compounding frequency. So our coupon rate is 10% times 1,000 divided by 2. So $50 every 6 months. Now this is a 10-year bond. So there are 26-month periods in a 10 years. So you're going to receive that $50 payment 20 times. Although this bond is callable after year 5. So if we're calculating the yield to call, we need to only make our timeline to year 5. And there are 10 6-month periods in 5 years. So our N is equal to M times N. 2 times 5 years gives us 10 periods. Our present value is $1,135.90, and we do need to make that a negative because we would have to pay that to purchase this bond. Now our future value is no longer equal to our par value. It's equal to our par value plus the call premium, because remember this is being refinanced, and so we're going to get that penalty. So the par value was $1,000. Usually call premiums are set to 1 interest payment, so $1,050. So we're going to receive $1,050 if the bond is called and the $50 in interest. So let's calculate the yield to call. We have all of our information already drawn out. So let's go ahead and plug that into our financial calculator. The first step is to clear your time value of money. So we receive $50 every 6 months for 5 years, so that's 10 periods. We would pay $1,035.90 for this bond, and we're going to receive $1,050 upon the bond's callable date. So let's compute our rate. And we get 3.765. So our IY is equal to our R divided by M. That's 2. And so we get 3.765 as our IY, and that is equal to R divided by 2. So we have to rearrange this. So R would be equal to 2 times 3.765 to get our annual rate. So 7.53% would be the yield to call. So the reason why we have to multiply that by 2 is because this 3.765 is the 6-month rate, and so we're wanting to know what is our annual rate. And so if this bond were held until maturity, you would receive 8%. If it were called, you would earn 7.53%. But you should expect to earn 7.53% because the bond could be refinanced at a lower interest rate, and this bond's already trading for a premium, meaning that it's paying above market interest rates. So market interest rates have already fallen. So you should expect to earn yield to call. In general, if a bond is trading at a premium, then the coupon rate is already set higher than the market interest rate, so you should expect a call. So you should expect to earn yield to call on premium bonds and yield to maturity on par value and discount bonds.